Good evening. Tonight we'll be working on the 6502 again, the break command, and trying to understand what it actually does. From my previous videos, I have... I'll just turn the volume down a bit for you. From previous videos, I've tried to use it, and it has not worked as expected. So we're just going to go through a 6502 emulator, which is that one there, that one there. I haven't loaded the code yet, so we'll do that now and see what we can find. Let's see. Does it load me to an embarrassing point? Cool, cool, and cool. That point where you just use any PC you can find, and oh, it's wanting source files. Okay, let's just try that. And did I split them up? Okay, let's try this. I was actually hoping it was going to read the binary file, but I hate it when it does this. Sigmund's head. Oh man. Oh, I hate it when it does this stuff. Oh, I really, really do. Let's see. Can I just open... Ah, man. Oh, yeah. Yeah, save as. I don't like doing it this way. Let's just save it at that. And let's edit and assemble. Where's that one? Remove the dots. What? Okay, let's open. Nope. Oh, tab spacing. So it looks like it needs tab spacing for it to work properly, and it is strict, and it doesn't like that one. This could take a while. I'm going to have to manually include defines.s. No, I don't have to do that. And we don't have to worry about the floppy disk controller. RTS. Oh, get rid of that one. Visual display unit, we're not debugging that. We can include. Okay, we will include it then. Oh, does it do if defined? No, it doesn't. We don't want to do that then. It means we just edit it out. We're not using those at all. Now we do. Can we do this? Edit. Find replace. Equals. With just straight equals. You are kidding me. Ah, caramba. Ooh, can I do a define? If I just want to define that contents. Let's see if this works. why can't I get help from this program? Because this program was made before a period of time. Okay, this is going to take some time. It was a suggestion I just do this on Twitch, and I'd probably get more viewers. And at the moment, 0 viewers is fine. Well, it's not actually. Nobody knows what I'm doing. This is a lot to get through. But that's okay because I'm not modifying the original file. I'm modifying a different file. And if I need to make changes, I can just easily make the changes through. If this works as more than expected, well, if this works better than on the hardware, it's either there's something wrong with the hardware or the compilation, the assembly is different. Okay, we need to get rid of that, and we do that. Cool, it's just looking out for little things now that may trip us up. No doubt there's going to be a few things, and we're just getting rid of things like this here. So I won't be starting this off at the end of the program. Well, actually the start point, the boot. I was going to say the boot sector. It's not the boot sector, it's the reset vector. It's not even a vector, it's just a reset location. And everybody calls it a vector. Now this should compile, but it will only compile when we get to the next bit here. So this is where we do this. And this will make it compile for these locations. Your origin, this tells the assembler or the linker that you want to actually put the code at this location in the ROM or memory. Alright, let's see. Assemble it. And what was this? The error? Okay, cool. I know what that is. That is going to be, it doesn't like the data there. And then B. Yep, and oh, missed that one, and that one there puts everything at origin FF00, which makes it all easy for other programs to find. These are just BIOS functions in reality. I'll just call them FF functions because they start with FF. What do we got? So what we're looking at is we're working through here. So the plan is finding that address there. What we can do, if I scroll up, is I'm just going to borrow a line of code here and place it. Where are we placing it? Down here. In this, I'm just giving a different message. And that means that after this null, we will find the basic code in the disassembly. Or not the disassembly. I didn't like it. Alright, so is that the same as what we've got there? Okay, that's 1A. It's different to what I originally had. And that is 4F. And 4D. Because we've got 64 rate instead of 1 times rate. This wasn't one here. It was originally for an older, the first generation of what was I call it? The first generation of this board, where the serial processor was at a different place. Serial command, serial data, and serial data in. Interesting. I got 2 different addresses there. I don't know. Something wasn't going there. Right. Alright, let's focus on this one. Now, we'll go to a plan. File load. We will call file load up here. And file save. Okay, they're just 2 calls for saving and loading files. Did that work? That worked. Cool. Now we can enter the debugger, and from here we can see. You guys can't see it. This is not good. All right. Let's see. I'm just gonna have to add another page here. I cannot see that either. All right, bear with me. Window capture. PC. Actually, we'll just do a screen. Can I do screen? Video capture device. Window capture, display capture. Okay, so that should be the whole display, and if I bring this over to there, excuse me, you guys get to see the, okay, so this window that I've just moved, that is the processor. So it's got the registers and status, negative, 0, overflow, carry, decimal, break, and interrupt. So when we're messing with this, it'll start off an interrupt. Break will be set. The interrupt won't be. But program counter at the moment is set to 3000. If we go to the disassembly, let's see, disassembly window. Okay, so I'm surprised it's not there. And FF. So try and get up a page, down a page. All right, and so this is the disassembly, and it's right at the bottom. So E1CA is our reset vector. E400 is our interrupt vector. So this is where if we have an interrupt on the interrupt pin, the processor will go straight to that, and B, if we have a break, the processor will go through that one as well. Let's see here. So if we go to E1CA, we don't want to go to E1CA, we want to find E1. It's too far. It's a good start, E1CA. CDE. Scroll down. E1 E100, that is the reset vector. Oh, E1CA, yes, that should be the E100, but we're not looking at that. We need to go further down. So this is where, if we get to FF, or we could just look for the break. It might be an easy, oh no, the break's not going to help us because that won't help us find the yes. If we're looking for the break, that's just going to help us find the jump code, but we already know where that is. We want to find the code to do the break. And I do remember there was a no op after the break. No. Clear byte. That might be too far. At this point, you're probably saying, well, why don't you just go to... there it is. Why don't you go to the SED? SED BRK. The other disassembly. We could do that. We can go to the other disassembly and see where it should be. E4AD. Let's see if that's the same place. E4AD. E4. Okay. Interesting. SED, break. It adds break in again afterwards. So the run basic, this bit here does the message. So that gives us our message, and then that's the new line, and this is the jump code. And here it just adds the break and no up and no op. This one here adds break, no up, no op, E4C6. E4C6 is just straight to the jump. Okay, so that's going to break twice. Right. So if we enter here E4C6. No, I've lost it. I've lost where it was. E4C2. E4C. Okay, so E4C2 is the SED. Okay, so the code's in the same place, which is good. Now we can also bring up, if I move that there, disassembly there, and you guys can see it, which is good. We don't need that window. That one there can just minimize, which was the other monitor. Alright, so this is the disassembly is what we'd consider RAM. This is the memory window, and if we bring it up to 0 page, we can see let's bring it to the stack. There we go. The stack is 256 bytes, so that, ooh, it may, okay, let's get rid of that one. That's the 0 page. Okay, and then stack, that's the stack, that's what we want. And cool, during IRQ, ooh, interesting. Log, input output, ooh, input output. I've never messed with that one. And identifiers, what's that? Ah, right, that's our values. Cool. Now we want to not run, step over, step into, run to cursor, animate, restart, toggle breakpoint. No, we don't want to run it because running it will not be beneficial to what we're doing. Now, let's run it. So what happens when we run break? It is an interrupt. It sets the next two 2 bytes from here. So if that was my understanding, it's not that one, it's not that one, it's this one here that sets the next program counter address to E4C7. So that's where, and that's pushed to the stack as well as the status register. So we're going to see some interesting data go through here, but okay, that's not wide enough. Definitely not wide enough. Right, that's interesting. Alright, let's step through. So sed, and we got a break. Now set the decimal, so set decimal. So for basic, I'm not too sure if we need to be in decimal. And interesting, the window might be a little bit weird for you guys for some reason. Okay, sorry for the windows a bit weird. It's the screen capture is not that not the greatest. And let's go. I'm just going to quickly go live because I can't see what's going on here on the screen. So I'm going to have one viewer, and that's going to be me. And of course you can see the screen. That's terrible. That's terrible. All right. All right. Let's try this again. Yep. All right. This is not fair. Oh God. Well, the only thing I know that's working for me tonight is the microphone, and it is a new microphone, so the audio might be a little bit different. You may hear my rough, gravelly voice after a long day at work. And I can tell you, it is a rough, gravelly voice after a long day at work. Alright, let's bring up, oh, what is that one? No, that's not what I want. That's the, we can get rid of was one. There we go. This is the disassembly. Again, you guys don't get to see the right one. This is just terrible. This is terrible. Alright, this is the code. And this is where we're up to. We're at break at the moment. So our program counter is E4C3, which is the break there. Then if I step into, let's see, step into break, and then goes to did it? What happened? What? the debugger quit on me? Okay, let's reset it. Get rid of the memory and the input-output window. And set our... Where are we hiding here? Set our... Oh, jeez. E4CB 6. No. 2. Okay. And I could just hit run, but I really want to see what's going on. I want to see what is going on in the stack. I want to see what's going on in the 0 page. I know I can set a breakpoint. I just broke the debugger. Okay, let's try and toggle a breakpoint. Now the best breakpoint we can do is probably there. Okay, let's toggle that breakpoint and run it to that breakpoint. And we want actually to... Yeah, no, E42. C2. Alright, because we do not want to run any of that. Let's run it from that point there. See what we can see change and see what registers are loaded. Because we can look at 0 page. We're saving it to 50. So we can see what data we'll be adding into there, and to see if this matches what I'm getting on the processor. Let's try this. Let's do it. Okay, so what happened? Nothing. E4C3 break. It's what options? Okay, cool. Finish running program by break instruction, RTS instruction, or BB bytecode. Let's do that one there. Ooh, and we can do a start address too. Okay. Assembler. Ah, here we go. Extra byte after. There we go. Alright, let's get rid of that. No, we want that. But we want to assemble. Yes. Debug. Now. That means that we won't have an extra symbol after here, and break is not an exit to the program. Let's run this. First of all, we're going to set the base for C6. Nope. C2. Yep. Alright. So this time we can do a step into and see what happens. So we can actually single step the processor. We've set the decimal. So it's in decimal mode. We're not interested in that at the moment. It's just a convenient instruction for us to work with. And what should happen is that the return address for after the break is going to be here at your jump address. So step into. Now we can see that break has been set. Cool, you guys can see that, which is good. Now you've got something else you can see. Alright, P, which is your flags register, so we're not worried about that. That's just going to be those numbers there. A, X, and Y are all set to 0. We haven't set anything on there. And program counter is E4 at the IRQ processor. So now we should watch everything that happens at the 0 page, and our stack has a lot of data on it too. So what happens on the stack is, well, that's a lot. Just ignore that, because we can see that here. So this is where it could be falling over for my code. So disable interrupts, we will see that up here. Interrupt, break. Interesting. Let's see, single step. Okay, so disable interrupts. Load accumulator at... okay, yeah, I know what I was doing here. I might have to take some code out. And it's gone to a soft reset, which is what it should do. But we didn't enter any data into 50, because I need to go through and change that code again. Alright, let's stop that. And I've forgotten I'd actually done this bit here. And it didn't do a breakpoint there. That's right, we can ignore that. Alright, so this bit here. So instead of LDO, it needs to be PLA. PLA? Yep. Pull A, store it. Oh no, this is not PLA. Store register A. Store register X. Store the register flags, or the program status word, and those numbers would for debugging. So I may need the hash in front of those for it to actually work. I might have been pulling data from those addresses to store it. Alright. High and then low address. And that actually should work now. Cool. So what we'll do is compile, debug, E4C2. And that hasn't come up to where we are. There we go. It's at the set address. And what we can do is do this. 20, 30, and 40. All hexadecimal, of course. Alright. And that's the stack. Stack's empty. Cool. Alright, I was just thinking about something. And okay, so set decimal, do a break. On here we've got E4 E4C5, so that may be E4C5. E4C5 is that bit there. Yeah, E4C5, and that should be the flags. But I'm expecting to see 2C. Okay, so next one is disable interrupt. Now we're storing data. So first one we're storing is register A, so in location 50 from memory we're storing, or 53, we're storing 20. 52's got a number. There might be a bit mistake. Let's see here. The next one is storing X. Maybe not. So Y. 20, 30, 40. Okay, just ignore this this through here. Look at these ones here. So that's the address, that's the data, that's whatever it is, symbol. I'm not worried about these other ones. It's just going to confuse me. And the next one, step over. So the next one will be pushing the status word stack 2C. So if we do that there, 50 is 2C, 51, store it, which is, we've just pulled the address low, C5, and the address high, and we're storing it. So E4C5, going back to here, E4C5 is that one there. I've got an extra no op that I don't need. So what we can do is, where are we hiding here? Delete that one there. Now if I delete that no op there, that should then point to that jump address. And then soft reset. Because we don't really care, we're just going to jump to that soft reset, and that is going to give us the location here for our next, where we were supposed to jump from, or next instruction if we didn't have to hit the brake. Okay, so that works as the textbook shows it should work. Now, and that code is also pretty good. It works as expected on the simulator. Step into, and then we just jump to the soft reset. Alright, now we've taken out that so yeah, some stuff's not showing up. You just didn't see the command prompt I brought up to do the next bit, and yep. This is fun. What we'll do is the program the processor. That one there. I think it's monitor bin. There you can see it. It just may be a screen refresh is bringing it up. Yep, monitor bin, and we get rid of that. And I've loaded it. It's in the carrier. Program it. Unless there's a big ass delay. Yep, programmed. Take it out of the chip carrier. Put it in the computer. Bring up that one there. Turn it on. Reset it. Oh man, this is not good. Alright, so where did we... Oh, you guys can't see that. There we go. So I just loaded up the code. That is the new compiled code, and that should be where we're getting all our data. And according to my... It is slow. I wonder if my computer's having trouble. Alright, so breakpoint storage. So 50, 51. If I move to 0 and 1. Okay, that's not going to make sense when we do the next bit. But it just tidies it up a little bit. So let's make a comment here. 51, 52, and 50. Alright, remember those. They're in different locations than what we're about to look at. I just want to know where we are running basic from. Okay, so if I run from so if I run this now, yep, that'll disable the SCD. If I run from E4AD, so you guys bring that there. Nope. E4, nope. E4AD. Run it. Oh, this is terrible. Alright. You guys can't see that. It's a big, big mess. Whole display, let's get rid of that. Alright. And I want ed. Oh, putty and emulator can go. Alright, this time. So, we really need something to say technical difficulties here. Let's try that again. So what I just did before was ask it to load a program E4. I can't get this right. E4AD. Run it. Loading basic and things. Why there is an extra character there, I do not know. It's an artifact of something. And then if we go 50.55, we can see that E4AD is the address we jumped from. That doesn't make sense. Alright, so program status word 00. We're not indicating that we're doing a break. E4AD is the jump point here where we're from running basic. 7F and BF, they are, let's see, man. Okay, so 7F is register A, BF is register X, R register Y is 00. So 00 means it's the start of a line or something. So that is completely different from what I am expecting it to be. The other thing, let's check zero page. Not zero page. Let's check the stack. So we want to check the stack from 100 to 1FF. So that's the stack area. And we can look for those jump points. They may not be in there anymore. They may have been overwritten as we do pushing and popping. We could do a transfer S to X and X to A and then print it. See what that gives us. Let's see here. E2 CD, E1 CD. And, oh, I can do that. Haha. Oh, I just realised I can move one screen to a different screen. I've got two screens. I've got a OBS on one and the rest of it's on the other. And I've just moved my putty up to the other one. Cool. Alright, gives me a little bit more room to do things. And you guys are less, you don't see that. I've forgotten what I was going to do. And nobody's in chat to tell me what I was going to do. Okay, so what we're going to do, we were going to... right, let's go through the list. Because these are points at where the stack is being used. And I could probably write a bit of code to do to recover the stack and place it in a location. And let's do that. So let's go to our notes and let's make some. Let's do some code. All right. So first things first, we can do transfers. So transfer A to Y, transfer A to X, and we can go transfer stack to X. So TSX, which is BA. No, it's not based, it's just BA. S to X, transfer X to A, TXA, and that code is 8A, and then we can store STA, so we can do an STA, and we can do a STA to 0 page, so we do an 85, and if we want to store it to 0 page, we can store it to 0 page 60, and then from there we do a 20 FF0C, which is our 20 is our JSR. Is it JSR? Or do we just do a jump? We can just do a jump and forget about JSR, because then that just adds stuff onto the stack that we don't need to, because it assumes we're returning back from where we need to. So jump, direct, indirect. Okay, indirect. So if we're doing indirect, the address stores the location of the reset. If absolute, we just give it the address. So instead of 20 FF0C, we can do 4C. And that way we're not adding any extra stuff onto the stack, because my gut feeling is we're trashing the stack. Okay, so, and that's around the wrong way. It's 0C, 0CFF. Cool. And let's see here. Have we got that right? And we want to do a reset FF0C. There we go. A soft reset, and that just resets the stack for us. it makes a mess of it. Which means at this point it'll be relevant. After the reset it won't be relevant, but we can check to see where that stack pointer is. Let's see here. So go back to our notes, and I'm just bring this back to the forward one because it's a bit bigger on this one. And we want to enter at, say, 50. Yep, we're going to have enough room there. 50. BA, 8A, 85, 60, 4C, 0C, and FF. And then we go 50.60. And there's a code there. 50R. And it's ran, and at 60 we will see FB. So that's where the stack is here. So it's FB. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's there. So that's where the stack pointer was pointing. So and then if we do run the code again, 50R, because it's all reset, it's at a different location, BA, which is further down. BA. And if I do it again, will it go further down as well? BA. So that's interesting, that because each time it's reset, I'm resetting the processor each time. But the soft reset is probably doing something to those first few numbers. Let's see here, if we go 200.250, we're going to see those 02. Yeah, it's hard to say where those numbers are coming from, because that should be 2220 dot. Yeah. And something's not right there. Still a lot of things wrong with this code. And to solve that problem there, we do a soft reset with those interesting bytes in it. Alright, let's do excuse me. Alright, let's do a 50R again, and 60, it's FF. FB. So that's 100 to 200. There's data corruption in those line numbers. Go back to FB. And let's run the code for basic. Well, the run basic, but anyway, A9OD. Nope. E4AD. And we're still good. And then we go 50.60. E4 AD. I wish I had another chip to run. I have two other 6502s. They do not run on that board though. They run in a no-up generated board. Check to see if they're okay, but apart from that, there's really it doesn't work anywhere else. They don't work on the board. That's the only 6502 that works. I may probably have to get another 6502 to compare against, but that break doesn't work as expected. I could grab the 6502 out of the BBC Micro, but I don't want to trash that 6502. So I honestly am at a loss of why it is not jumping to, well, not setting the jump point to where I expect it to set the jump point. Because it really should be setting it to E4 C5, not E4 AD, which is where we jumped to. And checking the stack now, we're not going to see those numbers there. And let's have a quick look. I can't even find E4. There's 4E, but E4, EB, F3, ED. Interesting. What we'll do is cheat a little bit. So, I've gone past it. This is the list. I want this one here. Stack pointer. Let's add that. At location 56. So let's not worry about this. We've changed that so we see the address low, address high. And what we can do is, because I like doing things nicely, we can do it that way, address high, address low. That makes it a lot more easier to read for us as well. Alright, so if we can read them, we can automatically know where that address is. Let's power that off. And I just powered off the processor, and let's bring leave putty there, scroll all the way down to our break command. There's our break command. There we go. And now let's get rid of those there. That was debugging code that didn't work because I was loading the accumulator with data indirectly, and if those locations had data in it, good. They didn't, that's not so good. Alright, stuff that didn't make sense, and I understand why. Now we want to store stack pointer. Now this is one of those things that really makes what's the word here? Makes the 6502 not that great for multitasking. You can do it, but it's not that great. So we transfer get rid of that. And we do a jump, Cool. Alright, so we're storing this at BRK stack pointer. Cool. Transfer stack pointer into X, transfer X into A, and then store A. Cool, right. Build. How long have we got? It's been an hour, and we've gotten far. All right, I'm not going to bring you guys in to see the changing of the changing of the code. There we go. One second. Slowly losing my voice, so bear with me. I've also got a throat lozenge in, so see how we go. Alright, so you guys can see the screen. We've added the code. I've reburnt the EEPROM. Let's see what it does. Alright, so for some reason we've still got that interesting data in there. I'm not too fussed at the moment. It's just a bug. Whether it's a fatal bug, whether it's a fatal hardware bug, I honestly couldn't say. So 50.5F, that's what we've got there now, and we can clear that. We'll just clear it. And that's all cleared. So that's in the 0 page. Next bit is, if I bring up the listing, yes, that's changed. Run basic. We're never going to get to this bit here. It doesn't jump to there. So E4AD, run it, loading basic and things, 50.5F, which gives us E4F1. That's That's interesting. Because, let's see here. If I scroll all the way back up, we did a big change to the front of this as well. So E4, F1. So E4 is high byte, F1 is the low byte, program status word is the next byte, register A 0, register X is 0, Y is 55, the stack pointer is 10. The stack pointer is 10. That is a long way down. At the moment, stack pointer is not 10 because it's been reset. But that would mean that okay, so let's see if we can decode some addresses here. So F1DA, or is it 4FDA? Let's see. Got 10 E2 CD. CD E2. That's not an address, but E1 CD is. E1 is But let's go up here, scroll down. So the first things that are happening is that we load the stack pointer up the top, and then we set it. Clear decimal, clear carry, and then we enable the interrupts. Down through here, JSR here, echo is the first one we call. And then if we scroll up to echo, this may be why my I might be right. Okay, where is echo? I did change it. Here we go. So it does do a return to return from subroutine. So echo is E246. So what I'll do is I'll write that down on the notes. I was writing on a piece of paper, but we can write that down on notes. Let's see, we'll call that read stack pointer. Okay, there's only one participant. Read the stack pointer, but we're not worried about that. So echo is at E246. So if we're looking for it in the thing in the stack, it would be 46E2. And that's if I've got, yep, that's what we'll be looking for, 46E2. And 46E2, can't do Control F, can I? No. So do we see a 46 anywhere? I do see a lot of DAF ones. and which is F1DA. So F1DA is all the way down through here. No, it's all the way up here. And F1DA doesn't exist in our code, so that's a red herring. So those ones there. So those ones there. Let's see. What I can do is assume that the stack pointer is all the way up here as well, because we do have the code to read the stack pointer. But the concern is this bit here, is that the stack pointer is here, E2CD. It's gone all the way down through here before the reset. We are so far down the stack pointer, it's not funny. So where is it? Okay, so we're okay. Let's have a look at show echo. So echo push A, and then we down through here. It's just a jump, which there's nothing bad about that because it's not using the stack. That's probably where we're getting that funny character. Okay, so let's get rid of that. Probably tidies that up nicely. Because I'm also chasing another bug for basic, but this could be the issue we're having with basic, is that it's we're trashing the stack. Okay, so so we show message, we load Y 0, push Y. Can we push Y onto the stack? Does that affect how no, we can only push accumulator on stack and then pull from the stack. There goes that lovely fan again on a Raspberry Pi. Sounds like an angry little bee. Oh, I just dropped the book. Yeah, you guys probably can hear that. I'm going to deal with it. I'm not going to worry about why. It's really not. Yeah, I'm not going to worry about why. Uh, the issue's not in load intel because we're not using that. So that will be in here. And really the only time we're doing jump to service routines is when we're doing an echo or a message. Let's see here. Echo, message, echo. That's stack, not stack, not stack. Yeah, the only time the show message is through here, or when I'm calling it in basic. Loading the basic, which is the 2 points I don't really care about, because at the start of the program it is using it, and then the monitor will use it in its own way, and then going through to basic. Basic sets up its own areas and stuff, and it's not intended to return, so we're not worried about any other register or even the stack itself. That's why we've reset it back to 0. Which means if we're resetting it back to 0, then we shouldn't be worried about the stack overflowing. It's running, isn't it? Yes, it is. And it is running. Soft reset. Okay, I'm not resetting the base stack. Why am I not resetting the stack here? Okay, so what we'll do is back into the monitor. Let's find where we reset the stack. Because at soft reset, I don't do it at the soft reset either. I only reset the stack here. Okay, let's grab that. Run basic. Okay, so any issues, this comes up, and it will do a soft reset, at which point we can just press enter and it will do nothing. Here I'm not sure if I need sed, break, and no up have gone, and then we can do this bit here. which is load X and transfer X to the stack to set the stack address. Okay. Power off. Oh no, we were going to run the basic. That's what we were going to do. Which is DD10. Well, that's new. I don't know what it's doing. It's just writing a lot of data. Let's power cycle it and re-burn the ROM with the changes. Okay, so changes we have made. So we have commented out said break and note op, added in the stack reset, and it jumps to basic address. So save it, assemble it, load it, program it, so as you probably can tell, I've gone away from break at the moment. So it's not a bad thing because I've made some changes to make it work a little bit better for my needs, and reorganized where it is, how it is showing the data, as long, oh no, because if it resets it will do a soft reset instead of a hard reset. I might have to do a hard reset to reset. Oh no, hard reset won't work. Let's play it by ear. Yep, I've loaded it, and let's find the. I was thinking if I have to do a different reset on it. It's not a hard reset; it's a cold reset because the 8251 has already been programmed. It's just different resetting. Okay, so where are we hiding? So turn it on and reset it. Okay, see, cleared up that problem with that. Where was it? I'll show you where I fixed that. It was up here. It's echo and show message. This is where this part through here is where I believe I'm having trouble with basic. It is not reading it correctly. And forget the listing. Yes, it's changed. And the address has changed as well. E4AD. So E4AD run. Okay, and okay, so what just happened there? Do you think it's found a break? But loading basic and things, question mark S thing, syntax error, question mark ED, syntax error. So we're using echo. Are we using echo? We're using get character, and we're using character out. Now character out is the same as echo, but it's not the same as echo. Echo has Actually, if I do that there. Okay, we're bringing up character out and echo. Oh, if I could just get them to, yep. So echo and character out. It is pretty much the same, except we do not have the and 7F. The data coming from it is pretty much the same. The main difference is in the get character here. Now, this is the part I'm pretty sure I'm having trouble with. Next character. From my understanding, the set carry and clear carry indicate that there's a key ready to be read, or there's no key ready to be read, so it is used as a polling function. So serial command rx ready break equal no key, so there's no key press, clear carry return to sender. Alright, if there is a key press, then we load the data from it, and then okay. Okay, so if it is, do we want to do a convert? Because that's a convert there. Okay, so let's get rid of, oh, I gotta go back to, gonna bring this up into another view. Okay, how am I gonna do this? Ah, there we go, client to other view. That's cool. Alright, now back all down through here. Clear block. Now, just be nice. Okay, don't be nice then. Alright, so we want to get rid of that. We'll make some sweeping changes. Yeah, so this just polls and polls and polls. This here is polled, but it returns back to do something else. Let's see here. Serial data, compare. $60 and then BMI. Character convert, and because it's lowercase, we want to make it into uppercase. String 5F. So C character convert. Okay, so we convert it by ORA, and we string 80. And the rest of it is just displaying it, so we're not really worried about it. Question was, will that work? Oh, and I just realised what I'd done. You guys didn't see much of that. I had putty hidden over it. That's what I did. Basically, I was using the right-hand side to help write the left-hand side. That was a rookie mistake. Sorry. Right. Let's compile it. You guys can't see the compilation. I'm really not too worried about that. Turn that off. Turn that on. What's the next bit? We load it into our programmer. I really should tell this to create Intel hex format, then I can just press load instead of pressing some extra buttons, but I don't mind. Let's program it. And let's hope I have a win. Alright, fingers crossed. Let's see what it does. Cool, that's good. That's a good sign. It's a good sign. Okay, what we didn't do, let's see here. Bring that up. Oh, you guys can't see that either. Alright, where's putty again? Oh, yeah, right, there we go. Cool. Right. So the main changes we have done are just get character. That's all we've changed. And brought it more in line with the get character that we know works for the monitor. So let's see. I'm not storing it at location 79 like I was before. So it was DD10 run. Hey, it crashes. That's interesting. At least it didn't do a break. Guess what? We can do a break. Let's do a break right here. Probably doesn't matter. Let's just add a break right there. And see what's going on. Because we can save the stack pointer. That's off, that's off. Okay. So, let's see. Power on. I was just thinking, is it DD1? It is DD10. Now that is interesting in that we didn't get that far. So we didn't even get to the break character. Get character. It just failed right there. I think that works. Ah, that didn't work. See if that worked. That didn't work either. You're taking the piss now, aren't you? The mother... I swear, man, this is just BS. Okay, so what did I change? Because I didn't change anything up here. Oh, I did, didn't I? No. Get character. No, I didn't change anything here. Okay, cool. It's like when's a reset's not a reset. So it's going to be things like clearing the text buffer. Because obviously it didn't clear it properly. Reset needs a bit of work because to get it to get those zeros into there, I had to power cycle it. And if you've watched this more than once, you would have noticed that when I do power cycle it, there's a character that comes up, and then when I turn it back on, it normally does that without a reset. So doing the DD15R brings A2, and there's nothing on the processor. We do that 50.5F, so that was a reset, and 50 has data in it. Now this is not data from my break command, because unless there is I had in the break command one stage the echo to print a character. Let's see here. And it was just a good indication that we had gone them through to here. Let's see here. So we can do that again. Okay, so we're just going to do this. So load 0D. And then we're going to do load accumulator hash B. echo, and then control V again. So this is really going to tell us that we have... No, we're not going to do that. We're going to do this. Break message. And okay, how do we do? Oh, we'll just do that. How to do? It's already there. Cool, that's going to work. And power off. Take it out. Oh, for carrier. Compile it. No errors, which is good. It has been a while since I've had an error on there, and okay, so even though that my break function is not working properly on the processor, we can still use it by breaking and printing a message, oh excuse me, and not returning properly from a soft reset for whatever reason. And if it does print the message off, that's a good thing. Let's see here. Yep, and I'll just bring up the editor and then find putty again. Cool. Alright, let's have a look here. So you notice I've gone from DD15 to DD1, from DD10 to DD15, and DD10 worked better than DD15, so C8FF is in there, and I'm not sure where's osi.list. There it is. Oh, come on. You can see I'm tired. What was that we're looking for? C8FF. It's all lowercase. Okay, it's not going to help us. Okay, and good question. Where does our ROM start from? I know. got this all wrong. 8FF is what we're after. Nope, can't find it, eh? That is no good. Right. Okay, so 8 D E. Okay, maybe I've got something wrong with basic that I need to fix in the define, not that one. Defines for basic. Copy, that's the one I'm using. Defines OSI. Now, okay, that's always going to be config small. I mean, if I get rid of that, that changes everything. That changes the whole size of oops. That changes the whole size of everything. Okay. Yeah, it goes to 9K. Which is way too big for the ROM. 9,472 bytes. And it shaves off the bytes by removing or changing the error messages. So that's why we have that string or S and that funny character at the end. Or it's actually a null character. It's some sort of character. And those should still be the same. FF0, FF04, 08, 13, and 1B. So those should be all the same. Twenty-seven 1F23. And that just returns. And the other thing is I could do this. RAM start location. That means we're not going anywhere near the first RAM, we're just using the second RAM. And we're 4K instead of close to 16. Sorry, we're 4K. We're 8K, we're not close to 16. Yeah, it's got the extra 8K RAM there. And almost 2 hours. And nobody's watching. I ain't gonna get top chat, live chat, and participants. Nobody. Huh. Right. The algorithm hasn't interested anybody, I guess. Okay. What am I thinking? Do we reprogram the ROM for basic? Does that change where everything lives? It changes the size. Okay, that's interesting. Okay, so what I did was change the size here where the RAM start location is, and the size of the file increases. No, that's not what I wanted. It was wrong file size. There we go, 7.2. Okay, so if I set the memory to start halfway up the ladder, then it should work. If I have it all the way down the bottom of the ladder, it makes a mess, and then halfway up it works. So let's properties. Okay, shall we turn that off? That one there. What we'll do is actually save the first basic, and basic 1.bin, and then we load the other one. And program it. Nope, wrong way up. Okay. No. Oh, right. I can't change the data there. And DD1582, that sounds about right. So, hey, something happened. Syntax error. Okay, DD10. Again, syntax error. And we're syntax error plus. Are we back in the? We're back in the monitor too. And we're back in the monitor. Did I change the monitor code to? Let's see. Nope, that's not what I wanted. That one there. And let's see. Easiest way to check is if we have E4B 8. Far out, that's not right. E4B8 to E4BF. So, okay, so cool. Oh no, that's run basic. That's the wrong place. This one here. All right. E4, E9, 2. Where are we hiding? 2, E4, EF. Okay, so A9, 36, 85, 2C, A9, E4. Cool. Now, we know it returned back to the monitor via the break because it didn't crash, and the only way it can return back to the monitor is via the break. So, what do we have at the address below? 50 to 5F. Now we know where. Oh, okay, yeah, that's where we put the break in, wasn't it? We put the break in. We put a break in. Where did we put the break in? I thought we put a break in somewhere. There we go, get character. So at that point, it decided to fall over. But it gave us a question mark. What's going on? And then the question mark syntax error. It's like it didn't even want to get through here. And then it asked another question. I don't know. And decided to quit. Twice. But it didn't print that message we've got. So let's see. Okay, CC14. CC14. That's good. That is good. A CC4. Okay, let's decode. Let's decode. So CC14. I'll move you guys to the right here. To decode that. Okay, I'm lost. I'm looking for putty. Right, I'll move myself over to the same side. So, address high 14cc. Okay, that slow down in memory. Is okay, that doesn't make sense because that's okay, maybe it didn't. Okay, so we're here still. So 14cc doesn't translate to any address here. 33 is the program status word, 0 is the first register A, register X is FF, register whatever that one is, Y, stack pointer 0, 1. See, that doesn't make sense though, 50. Yep. That's now broken too. So it has done a proper it's done a reset, but I cannot enter data into that area now too, which means that at the location of where this here 24, no, this here 2B, oops, not what I wanted, 2B 00, which mode is it in? Now we can actually change that mode. So when it comes up, we are okay, so it's examine at the moment. Ah, right, because we can't change it. We cannot do anything there. It's just not in the mode it needs to be. And of course, a reset doesn't do anything. We still get that the 2B is still going to be that. 2B to C gets changed to whatever it is. To C is message location, message low, message high. Okay, which is from loading the that loading message. Ooh. I'm not sure if I'm using that though. Alright. Let's remove the break and okay, there's one thing I wanted to do. And oh, I've lost the mouse on this side. Let's get rid of that. Okay, and then we go control save. And nope. Oh, 2 hours. It's 10:30 and oh, I got work in the morning. Okay, so this time we are... Should I leave it on that side? Just trying to figure out where I leave putty. So, we've removed the no-op. We've removed the brake. We have RAM starting at 1,000, which is the second half. It's the second half of the ROM. Second half of the RAM. No changes to... Where are we hiding here? No changes to character out or character in. The only big change is the character conversion there to ASCII. Whether it needs to be ASCII, I'm pretty sure it does. Considering a lot of those old keyboards these things had were ASCII keyboards with the most significant bit set. So let's have a look here. DD15 or DD10. So yes, it's modified. Define server-side list. There we go. Yes. Okay, so let's see if we're getting to the right entry point for the basic, and to do that we look for cold start. Cold start. Right. So down through here on that left hand side, these are addresses. Left hand side is your code it's been loaded to. Okay, so A2FF8688. So we had to find that via, let's get rid of that one. I'll bring this up here. I just got sidetracked. And what's that on there? Browser. Bring that one up and change it to that one. Okay, so this is where we're looking for the code, the start code, and the four start bytes are A2FF8688. So we find, and I've forgotten the codes already, A2FF. And they should be, okay, there's two lots. 1D10 and what was the other one? $280. Huh. C280. Okay, so 9A. So it's not that one there. A2F6, control find. Oh, Jesus. There we go. So this one here, A2FF8688 9A A9 9A A9 A0 85. And this one here is just loading addresses. So we are 86. Where do we say? A2FF. So A2FF. Now A2FF here is literally load X that data and then store current line +1, and current line is 88, and that's 0 page 88. Oh, man. Seat. I've been sitting in the same place for too long. Let's see here. And it's been, 2 hours and 10 minutes too long. And I'll be surprised if you guys are actually watching this for this long. Okay, so I didn't find that address, did I? And so we're looking at that one there, which is 1D10. 1D10 and a pen. So this is in the ROM, it is 1D10 offset. And DD10 is where I've been trying to start the code from. Has been working from there for quite a while. Well, so let's see. So DD, yeah. So that's DD. It's not DD10. DD15. DD10 is further back, and that's where, if we look at the code, yes, yeah, so the further back DD10, this here, 20A0. Okay, yep. And then further this bit here is the actual code for writing the I've just drawn a blank. Writing copyright Microsoft 2002. It's not 2002, it's 1977. And that's somewhere else. So DD15 is what we're loading in. So I've just written that down somewhere. For cold start, and that's hard coded into the other code. And right down the bottom is all the copyright stuff. The biggest concern is this stuff up the top here, and I'm not sure what's going on here. I'm not sure if that's code or that could be a table or a lookup table. Yes, don't worry about that. Okay. Getting sidetracked. Process is still on. Oh, you didn't actually see that because I haven't brought it up. Okay. So what I've done is in PuTTY looked at where we're loading DD10, but it's not. It's DD15, which is A2FF86889A. That's the start there. So that's the cold start location. And each time we try and run it, it either crashes and goes back to the monitor. Yeah, actually, that crashed and went back to the monitor without a break. Let's see here. I think I got a break in there. Okay, break. Nope, it's all commented out. Okay, cool. That there's all wrong too now. Alright. Okay, I'll move you guys back to... Yep, I'll move you guys to the right. Alright, so that means we can see where it tried to jump to, write code from. Well, it's got a return address of 00C1 and a break is literally 00. So if it encounters a 00, it will literally do that. And C1 is FF, which doesn't make sense. So C to, oops, C0 to 00 F0. Okay. Okay, similar result. It's oh, 93 E7, 31 is an A, X, Y, A. Oh, PSW, X, Y, A, stack pointer. Stack pointers FC there. Yep. It still comes back with a syntax error. 79. That, for some reason, made it work. We'll better turn it off. I feel like I'm going around in circles. It literally feels like I'm going around in circles. Okay, you guys can see the code, and if you didn't hear that, I'm losing my voice. Okay. Let's clear that. Cool. Didn't need to clear it that far, but that'll do. DD15, run. There you go. That failed as well. Let's get an or 80. Didn't and 80. Yeah, 93C. that's above the processor, but yeah, it's well outside of the range of where that loads. It loads at C. What the F? It's like it's compiled in the wrong place. I would hate to think it's compiled in the wrong. Oh my god! I know what I've done wrong. Like I said, I'd hate to think it's compiled in the wrong place, and then I'm like, oh my god, I've just may have compiled in the wrong place. So we need to change the OSI config because I assumed it was everything was the right size. So the basic ROM it starts at C000 and you guys can't see this next bit, which is good. So I'm going to my desktop. That's not important. Just getting rid of the emulator. That gets rid of that. Okay, so I want KiCad. Okay, I'm going to bring you into the basic module. Bear with me. KiCad. I don't think you guys are going to be able to see this. Okay. You guys can't see what I've got there. That's it's not good. I'm disappointed. It's not my fault. It's not OBS's fault. It's nobody's fault. It's just not supported. Right, let's have a look at KiCad and where I have my ROM and RAM loading. And so ROM is loading at address C000. RAM is at 2000. So, and that's hex. And then looking at our, let's get rid of KiCad because you guys can't see it. It's not important anymore. Looking at our loading C000 size 3F0. Let's see what happens if we change that size. So I want, okay, so 1 equals 8192 and hexadecimal 2000. So 3F00 is way too big. So 2123. Oh, let's just change that again and write that down because I might have to restore it because it may be a mistake to change that as well because 3F00 is way too big. 2000. And let's see if this breaks it. .772 and let's burn that to, that's going to be turned off, otherwise we'll fry another chip. Well, not fry another chip. I've come close to it. I managed to put the chip in upside down and I can smell burning. And the flash chip got warm. And now it is running the monitor, so it's still fine. Let's see, program. Program that. make sure it's around the right way, otherwise we could destroy it. It's verified as well, so that's a good thing. And if this works, I promise I will not do a song and dance. Okay, so that's a good sign. That's a good sign. That's still a bad sign. Why? Why? Unless it's supposed to be E793. But E7's not even... That's not even... That's what is E793? Forget what I said about having the first high and low high, high low. E793. That's... No, because if it was calling anything an E793, that would be an FF function. Not this. Not this here. Oh! Okay. Okay, so we did something there and we fixed something. Okay, so what did we do to fix that? We did something here, didn't we? We changed this. Okay, so... Okay. But... this here. Okay, so we're going to change something down through here because that's sort of echo. Character outs, character in, character converts. Ooh, right. That's what else we did. We turned that off. I cannot remember if set works set decimal. If it's decimal or not. Cold start doesn't set it, so let's see, what are we? 2 hours and 30 minutes. So we'll do one more reset and then we're going to call it a night. And if basic works all of a sudden, I shall write a small program and see how we go. Ooh, I gotta build it. Oh, actually, before we do that, there's one other thing I want to do. And yeah, so if this fails, we're fine. If it doesn't fail, we're fine. There's just one last thing I want to do before we end for the night. And I do think this is a cool idea. And it is related to debugging. Honestly, it is. Alright, that's the one I want there. And alright, so I'm going to bring that to the right. Bring it to the right for the code. Ooh, wrong screen. That one there. Cool. And let's see here. Okay, that needed a reset. That's one line of code changed and it needs a reset. Come on, get with the program. Alright, what were we doing? DD15R. Nope. I don't want to know. So it's 93003, 93E7, 93C9. There's a small pattern there. It's like trying to call code, it cannot. Let's try actually finding that. It's OSI listing. Yes, and okay, so 0393. Try find 0393. Okay, cool. It's 0393 there, but that's going to be C393. Okay, find next. Is another one. That's the only one. Okay. Okay, the cool thing. I'm going to bring that over. It's to do with... Nope, I'm going past it. It's to do with a text string. This one here is getting relatively long. And we can do this here. Can we? You can do that. Oops. Okay, it's over by one. And I want to add in here. Let's go to... I'll bring you guys into it as well. Actually, I'll just grab the... Get rid of putty and browser. That's not browser. Oh, that's not browser, is it? Because we got to the wrong one. There we go. On there. Now, that is to do with configuring the text, and let's go through here. Address, nope. I may actually have to do a search for it. Ooh. Ooh. Okay, .p02. I wonder if that's going to have an effect. Okay, this is a little bit of sidetrack. .p02, where's my code here? And if we go all the way up, it was a capital P. It's capital P. And then if I do the same and defines dot, oh, got rid of it. Okay, I'm gonna be annoyed if this works. Defines OSI. Okay, so that's O2 mode. And does that do anything for our build? Oh right, because it's okay, so and that may have caused that to be okay. Unexpected end of line. Wrong one. I'm surprised that didn't work. P02. Okay, I'm going to change over here. Where are we? And are we linker or are we... Okay, it's the linker one. What I'm doing is changing the CPU type and just making sure we're hard coding that to the 6502 and nothing else. Ooh, and I gotta change that in that one there. Cool. $4.89. What? I've done something here. Oh. Yes, yes, yes. Right. Okay. It's alright. P02 is going to work. I just left something in that line that I shouldn't have left in that line. Yep, cool. Okay, so I didn't find the cool bit. I found something else a little bit more may work-ish. I doubt it. It's 11 o'clock. It's probably a little bit on the long side tonight, but yeah, like I'm on a roll. Cool. And I'll just bring you up to putty and remove that. Bring myself into there. So what I've done is I'll make a comment on here. This is the 6502 code basically. It's all it's telling us. It's 6502. And what effect that has on our processor, we do not know at the moment. But it should give us a good indication of whether things are working as they should. And cool, that's cleared. And I may have to change the... Jesus Christ, that just worked. What the bloody hell just happened there? Sugar. What the... Oh, well. Okay, that was unexpected. Wow. Bytes 3. Nothing. Geez. I didn't expect that. That's a little bit of a one. I'm not sure what happened there. Clear carry. And let's try removing that one there. GD15R. Yep, it's gone back to doing its normal. I don't want to know about you anymore. Yep, and then it does that again. Okay, so for some reason it worked, and then it goes, no, I don't want to know about you. Yep, syntax error. And so whatever it's doing, it's going, no, you've got a syntax error. I don't know what you're on about. But it did read the return. That's cool. Now it's going to work now. Alright, so the issue is actually down through here. But like I said, I want to try something else. I'm not going to... I did put the P0 in there. So what I'm going to do is build the OSI again. And then I'm going to actually burn the OSI ROM. See if that works. Okay, so this is the new OSI ROM, in quotes, with an untouched monitor. Did that boot? I guess it did. Okay. Yep. Back to its old tricks. Okay. What we're going to do is up the top here. I'm going to keep carry as that. Clear carry there. And now I'm going to do is tell it or set carry. Character outs. So clear carry again, so there's no to make it think there's no key. So CLC and Let's remove that. I've been removing that, adding that, removing that. I don't even know if that works for it. It may not. B3E9. It's not an AC. It's not an address it will work with. So I think that's just bullshit data. Right. This time, after this time, I'll do that cool bit I was thinking of. It's probably not going to be cool. I think it's cool though. I can't believe it actually sort of worked. It's the code I've got's not right. Alright, let's program that. Cool, that's programmed. And put it in the slot. Let's go to basic. DD15R. Syntax error. Oh, wrong one. Press the wrong key combination. I can't do a control reset on this. C8 FF. That's where it crashed. That is success. 8FF. Where are you hiding? Right, I'll move that to the right. Okay. So we want the list, yes. OSI list, yes. And we when did we crash again? Sorry. C8FF. So we go 8FF. Please be an 8FF. There's not going to be an 8FF, is there? There's no such thing as an 8FF. Transfer S into X. SEC is set carry. Okay. Something's not happening with the stack. Config small. Okay, it is defined config small. Yeah, I don't know what's going on. It does sort of did work for a bit, and then didn't work for a bit. But let's go back to the browser, and let's not get sidetracked with something that may have actually made it work for a bit, and then not work for a bit. There it is. And we don't want the command lines at the moment because that is working fine for us. And what I'm looking for is to no. Okay, so I want a way. Yeah, line count. It's not quite what I want. Ooh, pseudo variables. Time. That's what I want. Now the reason why I want time is at the end here, monitor 0.1. I want to add the time to say when it's created. So we will find the code that I want. I think this is going to be helpful to us just in case I've forgotten to add something. Comma? Can I do comma there? Is that going to break it? Range error, not in the range. Are you kidding me? D word. Okay, cool. We'll get rid of that. Oops. Get the space there. Actually, we want dot byte. Oh, you guys can't see what I'm doing. Nobody told me. It's not my fault. Yeah, there we go. And you still can't see what I'm doing. I'll move that to the right. Actually, let's just get rid of that altogether. Okay, so what I'm adding is time to this bit of code here. And without that, it all falls over. And then that should do the job. Cool. Getting uncomfortable in my chair. It's almost 3 hours. Alright. This time it's the last time. No pun intended. That compiled, and I'll grab putty and grab my monitor. No, who cares where it is? And turn the processor off, turn that on, take that out. It's probably just going to be a big ass number. There's probably going to be no processing whatsoever on it. And it's just going to look funny. Okay. Not what I wanted. And I may have stuffed up. Ah, yeah, there we go. That byte is supposed to be there. And that can be there. And that breaks everything up nicely. And excuse me, that doesn't do time too well. Alright, the other one I did notice was in there was the version. And I'm going to bring the program, the browser back in. And yeah. And POSIX standard, second since the epoch. Okay, so that's why that didn't work for me. It would have been nice if it did the job nicely. What else we got in here that I could use? Really, what I'm looking for is a way of incrementing a variable to indicate either version or the time it was what's it called, compiled, assembled, and then that way I don't get to the point where have I assembled it, have I not assembled it, and getting stuck in a loop. I'm not sure where I'm going. Testing something that would have worked, but it didn't work because I didn't actually load it, type scenario. So, but we've had a couple of wins, sort of win. I can see the break command's not working as expected, as compared to a compiler, as compared to a simulator or emulator, but it does give us enough debugging information to know whereabouts we could be having trouble with code. I'm pretty sure I've narrowed down where the issue is with the code, and that would be the where we're getting the characters, or the character input. You can get indication here. And yeah, you just crash. I think it's going to do the same thing again. Yep. And it gives you a syntax error. Sometimes it works, sometimes it doesn't. Which is annoying. Actually, come to think of it, that's extra data in there too. So power cycle it. Okay. Because I can always do this one here, the run basic, and this will reset the stack. It's not killing the zero page as well, so it could be reading rubbish in the zero page. It could be expecting that well, it shouldn't be expecting anything. It could be expecting parts in the zero page loaded up correctly. And I could have a look at the OSI boot ROM to check that out as well. I could do that and go through it. We could do that tomorrow. In fact, let's do that tomorrow. So OSI boot ROM. Or is it the monitor ROM? So it's either going to be tomorrow or Friday I could do that. There you go. One last thing. E4, B6, and R. It has been power cycled, and we should see the boot load message. A9. And it really didn't like that, did it? Hey, wait. That C100, but that's not C100. It's 00C, and FE is the I'm not too sure what's going on. Like I said, I'm not too sure what's going on. I'm noticing a pattern here. This is me getting distracted after when I said I'm going to stop. And I try something and it's like, okay, no, I don't want to stop. And then it's and we get to this consistent pattern. Okay. I get the feeling that I may actually have to go through the OSI or read up on the basic again, because I could be missing a step. I feel like I'm missing a step. I think I'm missing a step. Right, with that, I am actually out this time. It has been 3 hours and 4 minutes of stuff and things, and I am out. We'll see you later.